So far, our indeterminate forms, those are things that we can't just reason through and figure out the limit. And so we found, the first day we talked about 0 over 0 or infinity over infinity. Okay, and those we just did L'Hopital's rule. Yesterday, we talked about infinity minus infinity and 0 times infinity. So infinity minus infinity, our strategy was common denominator. And then we should be able to do L'Hopital's. When it was 0 times infinity, our strategy was to write as a quotient by putting the reciprocal of one of them in the denominator, and then we can do L'Hopital's. So these are the 4 indeterminate forms we've discussed so far. Today, we are going to look at the final few indeterminate forms and talk about our strategy for those. So we're going to look on page 306, and we're going to read the indeterminate powers piece. Okay, so what that's saying is we have 3 other types of indeterminate forms. Okay, and these are all things that arise with powers. So if we have 0 to the 0 power, if we have infinity to the 0 power, or 1 to the infinity power. Those are indeterminate forms that we can't just look at and decide the answer. Now our strategy for these is going to be a little bit different. What we're going to do is add a log use the properties of logs to simplify. And then we will be able to do L'Hopital's. Now, we can't just change the problem. Okay, if we have, let's just think simplistic terms. If I say 2, 2 is not equivalent to the natural log of 2, right? But if I said e to the natural log of 2, isn't that equal to 2? Because an e and the natural log cancel each other. So when we do these, we're adding a log. We'll do all the work to simplify. And at the end, the answer will be e to that power. So we're going to add the natural log for now, do all the work to simplify it, and then we have to put the e in to cancel the log that we added originally. All right. So we're going to practice some of these today. Let's look at this one. All right, if I put in 0, sine of 0 is 0, so I have 1. Cotangent of 0 is undefined. There's an asymptote there, so it's like a 1 to the infinity power. That's an indeterminate form. We can't simplify it. So what we're going to do is add a log. I still have my limit of this whole thing. If I'm adding a log, then I know my final answer, I have to have an e to cancel it. So I'm just going to kind of make myself a note of that. My final answer will be e to some power. Now, the reason the log is nice, properties of logs. What happens to exponents? They come down in front. Now, we can't use L'Hopital's until it's a fraction. But currently, it's like the multiplication problems from yesterday. How did we take a multiplication problem and write it as a division problem? We put the reciprocal of 1 on the bottom, right? You don't want to try to do the reciprocal of a log. Always leave the log on top. But if I want to move cotangent to the bottom, the reciprocal of cotangent is tangent. Okay, so now sine of 0 is 0, so we have the natural log of 1, which is 0. Tangent of 0 is 0. So now it's 0 over 0, which means
We can do that.
we can do L'Hopital's. So it's a bunch of fancy algebra to get to the point where we can do L'Hopital's. L'Hopital's rule says if it's a log, 1 over the argument, but chain rule there, so derivative of, okay, the inside, so I have 1 over the 1 plus sine 4x, then derivative of the inside. Derivative of sine is cosine, angle stays the same, but then we'd have to multiply by the derivative of the angle, so derivative of 4x is 4. On the bottom, what's the derivative of tangent? Section is really good for making us remember all of our derivative rules. Okay, let's see if this is something we could simplify. So we have a 4, cosine of 0 is 1, over 1 plus the sine of 0 is 0. On the bottom, secant of 0, so cosine of 0 is 1, so secant is 1. So we get 4 for our answer. Now remember, that's when we added the log in. It all simplifies to 4. So to cancel the log, we have to have our e, so our final answer is e to the 4th power. Currently, if I plug in, I have 0 to the 0 power, which is an indeterminate form, so we can't evaluate it. Our strategy, we have to get rid of the exponent, so that's when we add the log. And I know if I added a log, my final answer will have an e in it. Properties of logs. The reason we choose the log is the exponent can come down. I need to write this as a quotient. So I can't move the natural log to the bottom. How do I move x to the bottom? X to the negative 1 or 1 over x, either way you want to write it. Okay, so now, natural log at 0, that's a vertical asymptote, it's approaching negative infinity there. 1 over 0 is approaching infinity, so now we have infinity over infinity, which tells us we can do L'Hopital's. So natural log will go to 1 over x. X to the negative 1 would be negative x to the negative 2. Negative x to the negative 2, that's negative 1 over x squared, so what could we do here? Mm-hmm. Okay, if we do that, we just get negative x, and we can plug a 0 into that, so we get 0. So my answer is e to the 0 power, or what's anything to the 0 power? Okay. I have several more. I don't know if we'll do all of them today. Let's jump to example 13. So if I plug this in, cosine of 0 is 1. 1 over 0, that's approaching a vertical asymptote. So it's 1 to the infinity power. So what do we do? At our natural log. Okay, adding my natural log tells me my answer will have an e. Exponents come down. And this one's really easy to write as a fraction. Just the natural log of cosine x over x squared. Alright, so cosine of 0 is 1, natural log of 1 is 0, so we have 0 over 0, which tells us so derivative of a natural log is 1 over the argument. We have to chain rule, so times derivative of the inside, derivative of cosine is negative sine. Denominator derivative of x squared is 2x. Okay. If you want to clean it up, we have negative sine over cosine. What is sine over cosine? Okay, so we could write it as negative tangent x over 2x. Tangent of 0 is 0, 2 times 0 is 0, so it's 0 over 0, which tells us, the tiles again. Derivative of negative tangent would be negative secant squared x. Derivative of 2x would be 2. So then we can plug in secant of 0. Cosine of 0 is 1, so secant would be 1. So we get negative 1 over 2. So our answer is e to the negative 1/2. All right. How are we doing? Do you want to do another one of these, or do you want to try some on your own? One more? One more, then I'll stop. And let you try your many, many homework problems.
Oof.
I think there's 4 of these today, so.
Mr.
I know, it's just really unreasonable, but you have a whole weekend to get it done, so I just didn't feel sad at all.
You know. Oh, yeah. More than 2 day week?
I wish.
Oh.
I'm hoping, right? We can hope that we get snow and.
I thought it was a 3 day week and
No.
give my hopes up.
I mean, there's a chance
Yeah.
of snow Sunday.
And Monday is weather. They changed it to, I saw the weather, Joan.
Uh-huh.
And it was 70% chance of snow Monday.
Oh, really?
So I'm not trying to get you.
Well, when I looked last night, it looked like it was all going to be rain, and they kind of switched it. But this morning they're saying snow again?
I didn't check this morning.
Oh, dang. Okay, well,
Oh.
if we don't look at it, it'll switch back to snow.
Oh, yeah, I agree.
All right. So if I plug this in, I currently have 0 to the tangent of 0 is 0. So what do we do? A natural log. Can I go ahead and just write my tangent in front? Can I do that in one step? And I know I'll have to have E for my answer. Okay, I need to write this as a quotient. So what would go on the bottom? How do I move tangent to the bottom? Okay. All right, natural log of 0, that's a vertical asymptote, it's approaching negative infinity. Cotangent of 0 is undefined, it's a vertical asymptote, so we have infinity over infinity, which means L'Hopital's. Derivative of a natural log is 1 over the argument. Derivative of cotangent. So derivative of tangent is secant squared. So cotangent is negative cosecant squared. All right, if you try to plug in the 0 right now, we're not much better off. Like on the top we get 1 over 0, cosecant's reciprocal of sine, sine of 0 is 0. Let's simplify this just a little bit. Cosecant is the reciprocal of sine, so that's like negative 1 over sine squared. So if we flip and multiply, we get negative sine squared x over x. Okay, that's still 0 over 0, but at least I don't have fraction over fraction anymore. So we have to do L'Hopital's a second time. Okay, so we have a negative sine squared. So remember, we think of that as a negative sine of x squared. So chain rule, exponent comes down, inside stays the same. Subtract 1 from the power, so it's just to the first, times derivative of the inside, derivative of sine is cosine. Over derivative of the bottom, derivative of x is 1. So at this point, we can evaluate. We have negative 2, sine of 0 is 0, cosine of 0 is 1. And we get 0. So my answer is e to the 0 power or 1. All right. At this point, you should be able to finish that worksheet that I gave you a couple days ago. So that is due Monday, but we're not going to move on Monday. Okay, we'll take 1 or 2 or however long we need to practice this, because I know there's a lot of complicated algebra within it, so we will be taking more time to review.